Over the next 2 days, we're going to take a look at the idea of finding surface area of your two types of polyhedrons and also then their similar type shape to them in a non-polyhedron sense. And what we mean by that is we're going to take a look at your prisms here today, and then the non-polyhedron version that kind of looks like a prism is going to be our cylinder. But since it's made up of circles, it's actually not going to have that idea of it being a polyhedron, because those circles are not polygons. Right? Today we deal with the idea of surface area of those two items. Then tomorrow we'll take a look at the surface area of two other ones when we get to 12.3. So taking a look at your opener here today, it says find the area of the base of the prism. So this goes back to what we talked about in 12.1, which was how do you identify the base? In a prism, your base is the non-rectangles. Well, in this case, they're all rectangles, right? But you actually have the option here. Your bases are going to be parallel, congruent polygons. So in this case, you could look at the front and the back to be your bases. These two rectangles are parallel to each other and congruent to each other. You could instead look at the bottom and the top rectangles to be your bases. You could instead look at the right-hand side and the left-hand side. Right? And it's up to you as to which one you actually see. So if I look at the top and bottom, your top and bottom, you're looking at those two rectangles that are 5 by 6. So the top and bottom would each be 30 centimeters squared. If you were looking at the front and the back instead, you were looking at the two rectangles that are 5 by 2. So front and back, we're looking at 10 centimeters squared apiece. And as I mentioned, you could also do the right and the left-hand side. So if I look at the right and left-hand side, you're looking at those rectangles that are 6 by 2. So they are each 12 centimeters squared. So it depends on which one you actually wanted to identify as being your base here. Now, in a rectangular prism, it is the only prism that you have an option for. Right? The rest of them, it is going to be the non-rectangle that is your base. Getting into the idea of surface area. Very first thing we have to deal with surface area is make sure whether we're talking about a prism, a pyramid, a cone, a cylinder, right, or some other type of shape. So a prism, as a quick reminder, is a polyhedron that has two congruent bases that lie in parallel planes. So in a prism, your base, in this case, is going to be this top hexagon and bottom hexagon that are there. They are parallel to each other, and they are congruent to each other. Now, your lateral faces, we talked about how a face is all those polygons that make your prism or pyramid up. Your lateral faces are your faces that are not bases. So they are going to be all these rectangles that come around. The lateral edges then are the edges that are made from the intersection of two of those lateral faces. So take two of your rectangles, and wherever they intersect, so there's one, and then we'll do the one right next to it over here to the left. Wherever those two overlap or intersect, that is what is known as a lateral edge. Surface area is what we're going to work with here in 12.2 and 12.3. Surface area, the idea of it is that it is the sum of the areas of all the faces of the polyhedron. Meaning it is the amount of paint it would take to cover it. It is the amount of wrapping paper to go around the outside of it. Okay? That's the idea of surface area. It's what is out on the surface area. Going inside, we'll deal with that later on in the chapter. Right? But that's the idea of volume. For right now, we are just looking at surface area. So adding up all those surfaces together. If surface area is all of the surfaces, and we talked about your lateral faces being not the bases, then the lateral area is the total of all of the lateral faces, meaning there is no bases. It is essentially like a paper towel roll. right? When you get down to that little piece of cardboard that's inside, you're actually looking at something that doesn't have a top and bottom to it. So there are no bases to that lateral area. Now, the way we're going to start looking at surface area is what is known as taking the net of your drawing. It is essentially taking the big cardboard box that you would have and unfolding the whole thing. Right? It is making a two-dimensional representation of that polyhedron. So it's taking this shape here that we had in the opener and unfolding it completely to make it look like this. This is what is known as the net of the drawing, that two-dimensional representation of it. So our next example says to find that surface area of a rectangular prism with a height of 2 centimeters, length of 5 centimeters, and a width of 6 centimeters. So they've already done the net for us. They've taken our drawing here and made it into our two-dimensional shape. So to find the surface area of it, all we're going to do is find the area of each one. So we have 5 by 6, which is 30, 2 by 6, which is 12. We have 5 by 6, which is 30. We have another 2 by 6, which is 12. We have a 5 by 2, which is 10, and another 5 by 2, which is 10. To find your surface area, then, we add them all up. We have 30 plus 30 is 60. Whoops, sorry about that. 30 plus 30 is 60. 10 plus 10 is 20. So we're up to 80, plus another 12 is 92. 92 plus another 12 is 104. So we are looking at a surface area here that is 104. And now surface area means that our units are going to be centimeters squared. Right? And that's how you use a net to find that drawing. Right? So as you're going through, it may be difficult sometimes to try to find that net of our drawing, right, and go through and try to do it. So we're going to take a look at another way to do it. When we look at our prisms, most of the prisms we work with are going to be a right prism. We'll talk about a different kind here also, but most of the ones you're used to seeing are known as right prism. It's a prism where each edge is perpendicular to both of those bases. So those edges that connect your bases together, they're perpendicular to them. Okay? That's what it means to be a right prism. Now, the other type of prism is known as an oblique prism. Essentially, it's just kind of leaning to the side, where your angles are not 90 degrees now. For surface area of a right prism, you'll see in your packet or your notes if you want to write it down, there's a couple different formulas that you can worry about. That surface area that is here, the one I want you to be concerned with is the first one, because it'll work for all shapes. To find our surface area, we are going to do 2 times that capital B is the area of your base, plus the perimeter of your base, times what they call the height between your bases. So we're going to look at a couple different pieces like this. Right? In my triangular prism that they drew here, my bases are the non-rectangles, so they're the triangles. So I'll be doing 2 times the area of the triangle. So I'd have to find the area of that triangle. Plus, now that P, that's the perimeter of just that triangle too. The perimeter of your base. Times that height, that HA mean is the height between your bases. So that is the height between the triangles. So I'd want to know this distance from one triangle to the other. That is why that would be my height. Right, so that is the formula that we're going to use. The only way to make any of these problems in the next 4 sections difficult is to make your base harder to work with. And I actually start this chapter off with the hardest example I can possibly give you. Let's take a look at example 2. Example 2 says to find the surface area of your right pentagonal prism. So my formula says it is going to be surface area is 2 times the area of the base plus the perimeter of our base times the height between our bases. So let's start off with what we know, what we don't know. So our 2 is there. Area of the base. Area of the base, well, we actually do not know that. We'll have to talk about how to figure that out here in a second. Plus the perimeter of our base. What shapes our base? Our base is a pentagon. So it is this pentagon right here. Right? We'll talk about finding the area in a minute. But to find the perimeter, well, a pentagon has 5 sides, and each side is 7.05 long. So 7.05 times 5 gives us 35.25. Our H, our height, wants to know how far is it between that top pentagon and our bottom pentagon. Well, that height they are referring to, that's our 9 feet. So we have 2 of our 3 pieces. The piece that is missing is our area of the base. The area of that pentagon. In chapter 11, we talked about finding the area of regular figures. To do so, this is where we're going to have to pull out our triangle and find our 2 pieces. So when we pull out that triangle, we know that this is 6, this is 6, right? Because they marked it right here. And then this bottom side, this side right here, is 7.05, because that's the length of all of our sides of that pentagon. Now, area of a regular figure was the apothem times the perimeter divided by 2. That apothem is the length that comes straight down and cuts that triangle in half. So this is still 6. This is a 90-degree angle, and that 7.05 is going to get cut in half. So it is 3.53. I need that. That's my A. That's my apothem. So it's just Pythagorean theorem. 6 squared will equal A squared plus 3.53 squared. 6 squared is 36. A squared plus my 3.53 is 12.46. And then I'm going to subtract it over. 36 minus 12.46 gives me 23.54. And then we just take our square root of each side. A equals the square root of 23.56 is 4.85. So my apothem is 4.85 times the perimeter of my pentagon. We already knew that. We wrote it down in that last example. Or the last part. I'm sorry. Perimeter. That was right here. That is our 35.25. So it is 4.85 times 35.25 divided by 2. And it gives us our overall area. Oh, I'm sorry. It gives us the area of that base to be 85.48. So that is what goes in for the area of the base. From there, it is just do our calculations. 2 times 85.48 plus 35.25 times 9. We get 488.21. The only reason this was a more difficult problem is because the area of that base was a pentagon. If that base is a rectangle, it's just length times width. If that base is a triangle, it's base times height divided by 2. Those are things you're more used to working with. A square, side times side. It is those regular figures that it gets a little bit harder. But I did want to show that hardest example because truly this problem is as hard as I can possibly make this chapter. We go from the hardest to probably one of the easiest. Taking a look at your cylinder then. The thing that makes a cylinder different than a prism is the base. A cylinder has a base that is a circle. So it is a solid. It's not a polyhedron because circles are not polygons. It is a solid with congruent circular bases that lie in parallel planes. A right cylinder is where if I join these bases together, I'm perpendicular to them. Now, essentially, if you were to look at the net drawing, it takes this top circle and it pops it up. It takes this bottom circle that would be down here, flips it down, and then it unrolls this lateral piece to it, which actually makes a rectangle. You're going to need this in your homework tonight. I actually don't know if you'll need it or not, but in either a worksheet or tonight's homework, you're going to have to know that when you unroll that, you have a rectangle here, where this is the height on the right-hand side. That's the height between your cylinders. This length, as you unroll it, it's actually the circumference of that circle. That's how you would figure that part out. Now, as far as your formula goes, once again, I'm going to make it easy for you. The only thing we're going to change, don't worry about that part of it. All I want you to worry about is this beginning part. 2 times the area of the base. Now, in a prism, it was plus the perimeter of the base times the height. But as we've talked about this year, you don't have a perimeter of a circle. There's no such thing. You can't add up all the sides. Instead, when you go around that whole circle, it is the circumference. So it's really the same formula. It's just, instead of dealing with perimeter, you're talking about the circumference. And then that base is actually easy to find the area of. Area of your base, pi r squared. Circumference of your base, 2 pi r. So you only need one piece. You need the radius. Take a look at example 3 then. It says you are wrapping a stack of 20 compact discs using shrink wrap. Each disc is cylindrical with a height of 1.2 millimeters and a radius of 60 millimeters. It says what is the minimum amount of shrink wrap needed to cover a stack of 20 discs? Well, if I stack these discs together, I end up with a little cylinder that looks something like that. That height, since each disc is 1.2, 1.2 times 20 gives me 24 millimeters tall. So, formula, 2 times the area of your base. Well, your base is a circle, so it is pi times 60 squared. So we get an area of the base that is 11,309.73 plus the circumference, which is 2 times pi times 60. So that is 376.99 times the height between those bases. The height between our circles is 24. And now we just do the math. 2 times 11,309.73 plus 376.99 times 24. We get 31,667.22 millimeters squared. Okay. So that's what we're looking at here as we go through to do these. Right? If you have questions, concerns, please email me. If you find a mistake, email me. I'll gladly fix it. Keep an eye. Make sure you're doing your work. Brings us to our last example here. Example 4. It says find the height of the right cylinder shown below, which has a surface area of 157.08 square meters. So once again, surface area of a cylinder is 2 times the area of the base plus the circumference of that base times the height. Here your surface area is 157.08 equals 2 times the area of the base. Area of the base would be pi times 2.5 squared. So we got 19.663 plus the circumference of the base is 2 times pi times the radius, which is 2.5. So I got 15.71 times that height between them. Well, that's my h. That's what we're after to find. So now it's just an equation to solve for h. I have 157.08 equals 2 times 19.63. I got 39.26 plus my 15.71 times h. Subtract over 157.08 minus our 39.26. We get 117.82 equals 15.71 times h. Take your 117.82 divided by 15.71, and we get h2 equal. When I round it, I actually end up getting 7.5. Taking a look at your units, we are dealing in meters. So my height is 7.5 meters. All right, take a look at your homework tonight. Pages 806 to 808, numbers 3 to 19, the odds. If you have questions, concerns, you need anything, please reach out, email me. Make sure we're getting our assignments in. Remember, quarter 4 is just a pass-fail grade. As long as you get most of your assignments in, you're going to pass for the semester. And then from there, it's a sliding scale based on your quarter 3 grade as far as what % you would actually get for quarter 4. If you have questions on that, you can email me. You can email your counselors. Just reach out if you need anything. All right, everyone. Stay safe.